Another nuance with hydraulic lifts is when you do push fluid down a distance, then our forces aren't exactly just a ratio of the areas. So, for example, if I were to draw the new level of this fluid here down here, we remember we have hydrostatic pressure, and so often this is not a significant amount because of the size of the forces that we're applying. But we do need to remember that there's going to be a hydrostatic pressure difference of rho GH that is dependent on that amount of fluid that's gone up. And so if we were to look at the force on this side right here, the pressure is going to be F1 divided by A1. That's the pressure on the inlet side. And then the pressure on the other side will be the pressure at the opening. So that's going to be, oops, sorry, that's supposed to be equal sign. So that's going to be equal to the pressure at the opening, so the F2 over A2 plus this hydrostatic pressure. Okay, and so solving for F2, we still want to find what's the force we can apply outside. Solving for F2, we'd end up with F2 equals F1 A2 over A1. So we still get that large change there if the area difference is large, but then minus rho GH. So we have to subtract off that hydrostatic pressure difference. Again, in many things like a car jack, it's not much at all. You usually can ignore that. But in fine measurements, you'd have to consider that.